is it possible to build the millions of houses that the low to middle income people need today in Africa? And the answer to that question is yes. And this is what we've been able to show by printing the first house in Africa. Who we are, 14 Trees is a company dedicated to affordable and low-income construction in Africa, may it be homes, schools, or clinics. We know the solutions to build more affordably and more sustainably already exist. They are in the labs of some startups, they are in the labs of some large companies, but where they need to be is on the markets. And this is our mission as 14 Trees. It's to take those technologies from where they are and bring them to the market and bring them to scale. And this is what we've been doing for the last 5 years in Malawi. Let's talk about this country. Malawi is a landlocked country between Mozambique, Zambia, and Tanzania. And it's a country which is facing many challenges. One of them is poverty, with more than 85% of the population living below $2 per day threshold. And it's also deforestation. Deforestation is a massive phenomenon happening in Malawi. And what you see here on the image used to be a forest about 20 years ago. And now it's just a piece of land where nothing can grow. We know the origin of deforestation, and one origin of deforestation is burned bricks, because people are using wood, are cutting trees to be able to burn the bricks that they will be using for construction. And you can see here on that picture that it takes twice as many trees as what you see on this image to burn the bricks into an artisanal brick kiln to produce enough bricks for a simple house. There is a solution for that. And that solution, we did not invent it as 14 Trees. It's a solution that even the Romans were using. It's basically the idea of mixing soil with a binder, and the binder being cement. And this is what the Romans were doing. What we are trying to do now in Malawi is to industrialize that solution, is to make sure that instead of using burn bricks, people are switching to that technology and are able to find it everywhere they live in Malawi. We gave it a name, we gave it a brand name, Durabrick, and we set up the production facilities to be able to produce that brick and make it available across Malawi. We started in 2016 when we opened the first plant in Lilongwe, the capital city of Malawi, and that plant has been producing bricks since then on 24/7. And we also realized that if we want really those bricks to be available across the country, to be available to the average Malawian, we need to make sure that we walk the talk. We say this technology is more affordable, let's show it, let's demonstrate it. And this is what we've been doing as a contractor, building homes made with those bricks at a price which make them really affordable for the people in that country. We've built houses for low to middle income people in that country, for corporations trying to build houses for their staff, for NGOs trying to build houses for their beneficiaries, and also for the diaspora, which is a great way to support the growth of the country. But then we also realized that to make those bricks even more affordable, we needed to change the way we were producing them. In particular, if we want to reach the rural areas of Malawi and not only rely on the fixed plants that we have in the two largest cities, Blantyre and Lilongwe. So in 2019, what we did is that we introduced a new way of producing those bricks. We reinvented our production process to make sure that everything fits in a container, and we brought that container as close as possible to the construction project we were in charge of in the middle of a village. And the great thing is that by doing so, we've been able to employ and train the same villagers that were receiving also those houses financed by an NGO. And it was a great way not only to reduce transport costs, but also to make sure that we empower those people in the villages and make them ready to switch to that technology. But let's be honest, making bricks in Malawi is a tough job. And it's really not easy to generate a margin and really sustain a business by just making bricks in a country like Malawi. So what we did is that we looked at the environmental benefits of that technology. And then we were amazed to see that this technology is saving a lot of CO2. Basically, for every 120 bricks that people use, we save a ton of CO2, a ton that would have been emitted if people had used burned bricks. And what we did with some partners is that we've been able to generate carbon credits that we now sell to some companies who want to offset their emissions. And those proceeds from those sales are now being used to grow the company across Malawi and even beyond the borders of Malawi. But is that enough to solve the school challenge, which is also an enormous challenge in Malawi? Just to give you a sense, more than 40,000 classrooms, according to UNICEF, need to be built in Malawi if we want every child to be able to go to a proper school. And the answer is no, we can't build 40,000 classrooms in the next 20 years if we use conventional methods, even if we have unlimited funding. And we built some scenarios. We looked, okay, let's imagine unlimited funding. Let's imagine that all the contractors that can build in a country like Malawi some classrooms are funded, get those projects and are focused on construction of classrooms. It would take more than 70 years to be able to build all those classrooms. So then we started to think, okay, why don't we train more contractors? Why don't we empower more entrepreneurs to become contractors in a country like Malawi? But that would reduce only by half the time needed to build all those classrooms. Then we came to the conclusion, which is the same as for the construction of homes. If we want to deliver millions of homes, if we want to deliver thousands of classrooms, we need to disrupt the way we build. And this is why we started to think about really disruptive technologies to build homes and schools in Malawi. Let's step back. Let's look at the way we build. It's been exactly the same or almost exactly the same for the last centuries. It's basically brick and mortar that have been used to build all those buildings that we built over the last centuries. We did not really change the way we build. But change is happening, and today there is really a way to disrupt construction by introducing digital fabrication in the construction process, and that is construction 3D printing. This is not just something that is happening in the Silicon Valleys of our world. This is truly something which is happening in Europe, and we've shown that it is possible also to happen in Africa. In 2020, we brought a 3D printer in Africa, and we've been able to print the first 3D printed house in sub-Saharan Africa. Now, let's have a look at the printing process of that house to give you a sense of what 3D printing really means. So this is construction 3D printing. It's a printing head moving on an axis, which is also moving on 4 vertical axes. That's the gantry system that we use, and you see here the printing head positioning layer after layer the mortar that is in the end forming that house. So you see here the printer positioning precisely the mortar where it has to be put, and that way we reduce the quantity of materials that we need to build a complete house. And all this is controlled by the technicians, by the Malawian technicians that you see on this video. And slowly, each layer is making that house a reality, and it took us about 12 hours to make that 45 square meter house. And that's just a quick version of that printing process, and you see how the walls and the windows are appearing. Now, let's have a look at the final result. And the final result is that house. That's a house whose walls have been printed in 12 hours and that we believe can be built at a cost of less than $10,000 in a country like Malawi. What we also did is that we conducted a life cycle assessment to understand what is the CO2 footprint of that house. How much CO2 does a house like this emit over its lifetime? And when we compare that with a house made of burnt bricks, which again is the conventional method in Malawi, we found out that it emits 70% less CO2 than a conventional house. So really, both in terms of speed, affordability, and CO2 footprint, that house is making very good progress on sustainability and affordability. But so this is also the interior of the house, and what's important is that it looks like a conventional house for the people who live in that house. But let's go back to the school challenge that I mentioned earlier. We also tried to build a school, and we did it. We did it in the middle of a village in remote Malawi, which is called Salima. It's a very small town near Salima on the shore of the Lake Malawi. And there we managed to print a classroom in less than 18 hours. And you see here that now this classroom is being used by some pupils that are now learning in that school, which opened in June of this year. Just one more image of those kids that are learning in that school. And you can imagine that when you visit that school, it's really fulfilling to see all those kids now learning in a school that makes possible to be built in that 18 hours, which means that it's easy to replicate that school and clear the backlog of more than 40,000 classrooms. Just to finish, that image of the printing process in the village I was mentioning, just to say that we are printing for people, but we're also printing with people. And the great thing that we achieved on that project is that we managed to recruit the masons who are usually involved in construction projects. We managed to train them and to involve them in the construction of that school. And this is the community coming during the night when we printed that school to cheer us up and to pray for the school that we were printing in their village. Thank you.